Good evening to everyone. So my name is Imanshu and I welcome you all to this webinar. So let me share my screen first. Kindly confirm is my screen visible? So good evening everyone. So I welcome you all to this webinar on EV powertrain architecture. So we'll be talking about the EV architecture. We know that the electric vehicles are gaining more popularity because of their zero emissions, and also the government of our country as well as worldwide are more focusing on to the EV. So there are many policies as well as the schemes which is being implemented for the development of electric vehicles. So there are lots of opportunities into this EV sector. So we'll be talking about the EV powertrain. So first of all, the EV powertrain, we'll be talking about like EV powertrain contains what are the different components by which EV electric vehicles are moving, like how the motors is being fitted, how the motor is being powered by the battery, and we know that there are different types of motors present, the AC, DC. So for that purpose, we requires different converters, like there is power electronics thing also implemented into the EV powertrain. Then talking about the battery, so we can say that so so we'll be talking about the EV powertrain now. So the agenda, or we can say that the content of this today webinar will be the introduction to EV powertrain. So we'll be talking about the different type of the EV powertrain, like what are the architecture. We have seen also the hybrid, the pure electric vehicle, and also the fuel cell powered electric vehicles. So we'll be talking about that. Then we'll be discussing about the different types of electric powertrains, like the hybrid. There are series standard, the parallel configuration. Then we'll be talking about the motors, like where we know that the motors are responsible for the traction of electric vehicles, like they are responsible for moving of the electric vehicles. So how this motor, what are the different types of motor, and we'll be doing some calculation related to electric motors, like how we do the selection of motors, like what are the basic calculation which is being required for the motor selection. And after that, we'll be talking about the battery pack. We'll be talking about the battery pack. We'll be understanding like how the different factors, or you can say the different terminologies, is being used to develop the battery pack of the electric vehicles. Then we'll be talking about the MATLAB simulation, in which we'll be seeing as MATLAB simulation of a pure electric vehicles, in which how the battery pack is being connected and the control system is being implemented there, and we'll be choosing a reference set for we can say a drive cycle. So we will see how the connections as well as how the we can implement the different EV architectures, and then for the calculation part, we'll be moving towards the MATLAB. So first of all, so this is our introduction to the EV powertrain. So here we can see that this is the electric vehicle. So electric vehicle consists of battery. So we can see the battery is connected to the power electronics. So this is a converter. So battery. So can anyone tell me like what type of energy the battery stores? Is it AC or DC? Yeah, from the participants.
DC.
Yeah, so a battery stores the DC power. So if we are using the AC motors, so for that DC to AC conversion, we require an inverter circuit into the electric vehicle chassis, or you can say powertrain. If we are using a BLDC motor or the DC motor, so there is no need of converters. Just the converter will be used for step up or the stepper in up step down of the voltage. So this is the battery pack. It is being connected to the power electronics, and that power electronics is being connected to the electric motors. And also in our electric vehicles, we have different types of auxiliary components like auxiliary part, which requires us very less amount of voltage, like indicators, headlight, tail light. So these are our horn. So for that purpose, what we can do, we can use a step down converters. It is a power electronics. So chopper step down chopper is, you can say, buck converter. For what do they do? They simply reduce the level of the voltage. Like input is, let's suppose in four-wheeler electric vehicles, they are giving a voltage of 200 volts. Sorry, 200 to 400 volts. So to step down those voltage, we give a power electronics, or you can say buck converter there. So this is a basic circuit of the electric vehicle powertrain. Now we'll be moving towards the next slide, which is about the types of electric vehicle powertrain. So first one we'll be talking about the series hybrid electric vehicles. So then we'll be talking about the parallel hybrid electric vehicles. Then we'll be talking about series parallel hybrid electric vehicles. Then the plug-in hybrid electric vehicles. Then we'll be talking about the fuel cell electric vehicles. So, and after that, we'll be talking about the battery operated electric vehicles. So all these electric vehicles, like talking about the series parallel, and the plug-in, like the hybrid electric vehicles, which are the hybrid, they are using both IC as well as the electric motor for the traction purpose. While talking about the fuel cell electric vehicles, they are using only motor. And talking about the battery operated vehicles, so into the earlier slide, we have seen the architecture of the battery operated vehicles. So this one is the series hybrid electric vehicles. So let me first. So for talking about the series electric vehicle here, this is the fluxes being connected to the internal combustion engine. So in internal combustion engine, what happens? The chemical energy is being converted into the mechanical energy, and then the energy generator is being converting the mechanical energy to the electrical energy. And this, yeah, hello.
Yes, sir, you're audible.
And the generator, what happens in generator? So generator converts the mechanical energy to the electrical energy, and that electrical energy is being used to charge the battery bank, which is being fitted into the vehicles. So for that purpose, if the generator is a generator is generating AC power, then the power converter will be doing AC to DC conversion. So for that AC to DC conversion, we require a rectifier, and that DC power will be used to charge our electric vehicle battery bank. And that stored energy is being used for the traction purpose. Like we can say simply, engine is not directly conducted to the transmission line of the vehicles or to the axles which propels the vehicles, but this engine generates the mechanical power, and then mechanical power and the electrical energy, and this electrical energy is used to charge the battery pack, and after that the stored energy into the battery pack is used for the driving the motor of the electric vehicle. And we have here motor drive. So can anyone tell me that what is motor drive from the participants? Like a brief idea, like what is motor drive?
The control plus the motor in all is called motor drive.
Yes, just to change, like driving an electric vehicle is a very dynamic process. Like so we need to suddenly increase the speed of our vehicle, increase the speed of our electric vehicle, and decrease the speed of our electric vehicle. So for that increase as well as to change the speed, like to control that varying speed. So for that, a motor drive is being used. So this is architecture of the series electric vehicles. So can anyone tell me an example of electric vehicle, any series hybrid electric vehicle? An example of the series hybrid electric vehicle.
Serious. Hello.
Yeah. Yeah, I'm asking the electric vehicle or the series hybrid electric vehicle. Can anyone name series hybrid electric vehicle?
Scorpio Micro Hybrid from Mahindra or Toyota Camry.
Okay. Yeah, and more.
Maruti Suzuki Grand Vitara.
Is it series hybrid electric vehicle?
Now, Vitara is a parallel hybrid, I think, sir, because both the motors and the engine is involved in the propulsion of the vehicle.
So for series, you can also say the BMW i8. So that is then also sorry, BMW i3. It is a series hybrid electric vehicles. So I think now you guys have the understanding of the series hybrid electric vehicles, like how it works, like the gasoline tanks contains stores the fuels, and after that, that fuel is used by the engine, and this engine generates the mechanical output, and that mechanical output is the input of the generator, and the input of generator is mechanical, and the output of generator is electrical, and this electrical energy is being used to charge the battery bank. So this is architecture of our series hybrid electric vehicles. Then we will be talking about the parallel hybrid electric vehicles. So into the parallel hybrid electric vehicles, so you can see here this is a gasoline tank, and this is an internal combustion engine. So this internal combustion engine is also connected to the transmission. So you can see here from the figure, and also into the previous slide when we are talking about the series hybrid electric vehicles. So the engine was not connected to the transmission. So here the engine is being connected to the transmission, and through the transmission, the electric motor as well as the generator, the motor drive, the power converter, and the battery pack is being connected. So into the parallel heavy electric vehicles. So there are few cases like there is only IC engine mode or battery mode, even the hybrid mode in which the both IC engine as well as the battery both are operating to move the vehicle, and then we have a regenerative braking. So can anyone tell me what is regenerative braking, and what happens to the motor into the region?
So regenerative braking is a method which is used to recover the kinetic energy and give it back to the battery. Like the motor acts as a generator in that regenerative braking mode.
So into this parallel hybrid electric vehicle, so you can see here whenever we decelerate or the kinetic energy is being produced while braking or deaccelerating, so the kinetic energy will be converted into the electric energy, and during that instant, this electric motor will be acting as a generator. So and that generator, sorry, and that generator will be give the power to the battery. So this is architecture of the parallel hybrid electric vehicles. Then we will be moving towards the series parallel hybrid electric vehicles. So you can see here the gasoline tank, the internal combustion engine, and here is the power splitter to splitting the energy either to the transmission as well as to the battery bank. So you can see here the internal combustion engine is connected to both with the transmission as well as directly to the battery bank. But in case of parallel hybrid electric vehicles, the engine was not connected directly to the battery bank. But in case of series parallel hybrid electric vehicles, the internal combustion engine is connected directly to the transmission as well as to the battery bank. So same thing here also happened. The chemical energy is being converted into the mechanical, and this mechanical energy goes towards the input of generator, and after that the electrical energy goes to the battery bank, which charges the battery pack, and that stored energy into the battery is used to drive the motor. So I think you guys are clear now about the different architecture of the electric vehicles, hybrid electric vehicles. So can anyone explain me the limitation of this series parallel hybrid electric vehicle or this hybrid electric vehicles? Like why it is not became a success, or you can say like there are few hybrid electric vehicles, but why everyone is focusing to only battery operated electric vehicles? Why not see hybrid electric vehicles? Can anyone tell me?
So the very first reason,
Yes, Neto.
The first one is the system bow visiting test the word okay.
Yeah, I'm not getting you.
Sir, maybe cost is one of the reason.
Yeah, cost is also reason. Like we are into this hybrid electric vehicles, we are using engine, generator, the motor, the battery pack. So it due to that, the cost is being also increased, and also they are taking a space into the vehicles. So because of that, optimization of the powertrain is not easy. So you can say that the
So
cost and
maybe the energy conversion is happening in each stage may lessen efficiency.
I didn't get you.
There is conversion of energy happening in each stage, right, sir? So
Yes.
the overall efficiency will be very much less compared to the normal.
Yes, yes, you're right. So because of the conversion of energy, there are some there is some decrease in energy, output energy. So because of that, lot of conversion, you can also say that the hybrid electric vehicles are not too much efficient. Yeah. So this is about the series parallel hybrid electric vehicles. Now we will be moving towards the plug-in hybrid electric vehicles. So in plug-in hybrid electric vehicles, so you can see here it is similar to. So anyone tell me like the plug-in hybrid electric vehicles is similar to which type of vehicles? Like I have shown the few architecture earlier from the part 3. Can anyone tell me which one it looks like?
Parallel hybrid.
So additional part is that plugin. So into which what happens there, we connect onboard chargers to the battery pack. So into the parallel configuration of the hybrid electric vehicles, there was no external mode for charging the battery pack. So the charging of battery pack was through the engine only. Like whenever there is a regen or the mode in which we are using the power from the battery bank only. So during that only we were able to charge. But in case of plug-in hybrid vehicles, there we fit an additional onboard charger, and because of that we can directly plug this vehicle to the charging point, and then we can charge the battery bank. So I hope you guys are clear now. So this plug-in hybrid electric vehicles contains both the gasoline tank as well as the charging port into the vehicle. So can anyone tell me like what is onboard charger?
Sir, can you repeat this question, sir? I don't get it.
I'm asking about the onboard chargers.
The charger which is inside in the battery, which is inside the vehicle.
So it is used for. So it is used for what charging? So is it used for charging or what? Or for conversion?
Sir, it is used for conversion of AC power from which we gain from the external devices to DC.
So Basically, if we had an onboard charger onto the vehicle, so in which what happens, the AC is being converted to the DC because the battery bank uses the DC power for the charging purpose. So for that conversion, we use the onboard charger. So can anyone tell me which one is fast charging? Which charger is used for fast charging purpose, AC or DC?
DC, sir. DC.
Yeah, DC. So can you tell me why?
Because the form of electricity is not transformed. There is no conversion.
Yeah, there is no conversion, or you can say there is a limitation into the onboard charger. Because of that, conversion and the efficiency decreases. So every time, whenever we talk about the fast charging, so just be clear that it is doing the DC charging. So this is a plug-in hybrid electric vehicles. Then we will be saying about the battery electric vehicles. So a simple onboard charger and the battery tank. Like into the previous architectures, the battery bank was not too big because of the IC engines were also fitted into the vehicles. But in case of battery electric vehicles, the battery pack is very huge, and because of that, uh, like overall the vehicle is being moved by this motor only, and that motor is being powered by the battery pack. So the only responsible for the traction of this electric vehicle is the motor, and to power up that motor we use the battery tank. So you can see this is a pure electric vehicle, so there is no hybrid concept is being used. So simply you can see here onto the screen that the onboard charger is being connected to the power converter, and then this power converter is being connected to the battery pack. So I hope you guys are clear now.
So,
Yes, sir. Yes, sir.
Then, so now we'll be talking about the fuel cell electric vehicles. So can anyone tell me like in our country how many fuel cell electric vehicles are present? Like an example of fuel cell electric vehicles.
Toyota Mirai.
Yeah, okay. So how many numbers are registered into our country?
Tata fuel cell bus.
Sir,
Where?
to my knowledge, it's with our road and transport ministers.
Yeah, and he is also having a Toyota Mirai, and also into the Kerala, there in RTO, there is also one Toyota Mirai present in Kerala as well as to our the transport ministers. So now talking about the architecture or the working involved into the fuel cell electric vehicle. So fuel cell electric vehicles have the fuel cell stacks. So fuel cell stack, what they do, they simply convert the hydrogen and they react whenever the hydrogen as well as the oxygen is being fitted into the fuel cell stack. There is the production of electrical energy, and because of that electrical energy, we can charge the battery bank, and that battery bank stores the energy, and then that can stored energy can be used for the for driving the electric motor, and hence we can move our electric vehicles. So talking about the fuel cell, so why it is being necessary to use a battery bank here? Can anyone tell me? Like I'm asking fuel cell stack.
Fuel output is very low.
What?
Fuel cell output is variable and it is low, due to which we have to use DC-DC converter with the and battery also.
If you are saying that the output of the fuel cell stack is very low, if we increase the numbers of fuel stack, then we can overcome that problem. So what is the reason? Like why only the fuel cell stack is not being used here?
Maybe it's easily.
Sir, instead of fuel, we can pour hydrogen as take hydrogen as a fuel, and we can use the vehicle.
No, in fuel cell stack, the hydrogen is only the fuel. There is no petrol or diesel being fitted into the vehicle. The hydrogen is
So
only fuel here.
like our conventional
Light is
automobile,
also an
we can use
alternate.
the hydrogen fuel and run whenever we want, wherever you want. If you go for battery driven vehicles, there you need to keep your vehicle for charging at least 30 minutes. So here it won't take much time. That's the difference.
Okay, so now let me explain. So talking about the fuel cell stack, so fuel cell stack didn't stores energy, but talking about the battery bank, they stores energy within itself. Like in fuel cell stack, whenever there is a continuous flow of hydrogen and oxygen, there will be continuous flow of energy, continuous flow of current or the electrical energy, and also the byproduct of fuel cells is water. So simply, whenever we give a continuous supply of hydrogen as well as the oxygen, there is a continuous flow of electrical energy. And to store that electrical energy, we are using a battery bank, and that electrical energy is stored into the battery bank. Now talking about the output, one guy I think from you once didn't know the name. One said that the output, yes, the fuel cell at initially the response of the fuel cell is low. To overcome that, like initially what happens, we require large amount of torque. So to overcome that, the battery as well as the some amount of some energy from the fuel cell will also give the power to the motor drive, and that motor drive will be giving the power to the motor, and the traction will happen. But whenever the battery and or the vehicles came into a motion, like there is no need of enough, and like there is no need of that much torque, then what happens? The battery will be discontinued, and when the battery is discontinued, the fuel cell, the whatever the electrical energy is being produced by the fuel cell is enough to move the vehicles. So this is how the fuel cell vehicle electric vehicles works. So I hope you are now understand with the clear with the concept of or the architecture of the fuel cell electric vehicles. Yeah. So can anyone tell me like what is the limitation of fuel cell electric vehicles? Like if the hydrogen is most abundant element, like it is present everywhere, hydrogen. Why this type of vehicle is not gaining popularity or not implemented into our transports? Like why? What is the reason?
Maybe because
So the cost of extracting hydrogen is very high, and we, as of now, we do not have infrastructure of hydrogen fuel pumps. Maybe.
Yeah.
also the storage.
Low well to wheel efficiency.
Yeah.
Due to stack charges, stack cost is very high if you compare with the electric vehicle. So due to that, it is very low popular.
Yes, you can say, and also yes, you can say the stack. Maybe if there is mass production of fuel cell stack, then the price may get low. But the main concern of the fuel cell electric vehicle is its fuel, like hydrogen. That the storage of hydrogen is very much difficult.
Very costly.
Yeah. Like we use cryogenic tanks to store the hydrogen. Like if this hydrogen is being stored into the tank, then we requires a large amount of pressure, and keeping that amount of pressure into a vehicle, it is sometimes very risky. Like if something explode or accident happens, then there is very much harmful. So the main concern of this hydrogen fuel cell electric vehicle is the storage of hydrogen also. So I think we have discussed a lot more things on to the fuel cell electric vehicles. Now moving towards the motors. So we are talking about the powertrain. So now we'll be talking about the motors. So basically, like in our academics, or in our home, we have seen electric motors. Like what happens when we talk about the fan, we simply turn it on, and it will be start rotating at a constant speed. We have a regulator. Because of that, the speed may vary. But talking about the motors that is being used into the electric vehicles, they should be very much dynamic. Like they need to be sudden increase, then sudden change in speed. So for that, what there are some advanced motor, or because of this advancement into these motors are of these motors, because of that the electric vehicles are moving towards this motors. So they are BLDC motors, PMSM motors, and the Synarens motors. So talking about the BLDC motors, so simply this motor didn't contains any brushes. Like talking about the conventional DC motor, these motors didn't have any brushes, and because of that, the maintenance of this BLDC motor is low as compared to the brush DC motor. And also, this construction, talking about the construction of BLDC motors, it has rotor and magnets onto the rotor part, and the stator part has the electromagnets. So the working principle of the DC motors involves a Hall effect sensor, and because of that Hall effect sensor, the detection of the rotor position is being there. And because of that detection, the controller of the BLDC motor gives information like which coil is needed to be excited for the rotating. So BLDC motors have high initial torque, and because of that high initial torque, these motors are being used for the traction purpose into the electric vehicles. Then we have the PM-SM motors, so which is permanent magnet synchronous motors. So talking about the permanent magnet synchronous motors, it is simply a synchronous motor in which AC supply is being given into the motor, and because of that AC supply, there is production of rotating magnetic field, and whenever there is rotating magnetic field present, these PM-SM motors have the permanent magnet onto their rotor, and because of that rotating magnetic field, they start attracting the permanent magnet, and then because of that, there is rotation. So this is these two motors, the BLDC motors and the PM-SM motors. They are widely used into the electric vehicles, like talking about the Ola at Okinawa. So this these vehicles have these vehicles have PMSM motors into their mounting, and because of their high initial torque, they are widely used. So talking about the BLDC motors, they are configured as, so you can see here onto the screen. So this at the center, this is an hub motor. You can see these are the rings. Okay. So simply what will happen, the tire will be fitted upon this part, and this wheels and this motor is directly fitted to the wheels of the e-bike or e-scooters. So these motors didn't take any extra space, like they are simply fitted into the wheels. Then we have the BLDC mid motor. You can see here, this is the mid motor, in which the rotating part is at the center. But in case of BLDC hub motor, which is this one, the rotating part is at the outside. The rotating part is outside. So this is the main difference between the BLDC motor and the hub motor as well as the mid motor. Then we have synchronous reluctance motor, in which these motors, if we talk about the normal reluctance motor, so they work on reluctance torque. In synchronous reluctance motor, now they are like at the rotor, the permanent magnet is there, and then because of the attraction between the magnet and to the materials which is being used, like they are highly magnetic materials. So because of that, there is formation of reluctance torque, and to fulfill the gap of the reluctance torque, this motor start the synchronous start rotating. So these are the mainly used motors into the electric vehicles: BLDC, PSM, and the synchronous reluctance motors. I hope you are here now. So we talk about lot about the EV architecture and the motors. So now we'll be do some like hands-on things in which we'll be do some calculative part. So let us take an example, like a simple example for your understanding, like how the initial calculation is being there, how we are doing the calculations to do the selection of motors, upon what factors the selection of motor is depending. So one by one, we'll be talking about that. So first of all, let I'm assuming I'm taking a vehicle of mass 1500 kilogram. Okay, so I am audible. So please try to be do calculation with me also. So let me take. So I am taking a vehicle of mass 1500 kilogram, and let's suppose the acceleration will be let's suppose 0 to 100 kilometer per hour in 10 seconds. So this is the basic prediction or assumption I am taking. Like after I produce a vehicle, I manufacture a vehicle that is weighing of 200 kilogram. Now I want to do the estimation like what will be the rating of motor I need to use for this vehicle. So for that, I want the acceleration that the acceleration should be 0 to 100 kilometer per hour in 10 seconds, like the speed. Then we need to take the forces, like why we see that different forces are acting upon our vehicles, like aerodynamic, rolling, grading, and also the force due to gravity, that is MC. So let me take the rolling resistance, which is for ideal condition, it is 0.03. Then the air drag coefficient. So this is all these things we'll be using. We'll be talking into the formula or the equations of the aerodynamic and the rolling. So first of all, let me give the written data of these things. So it is 0.3. Then we have the air density. So air density, it is 1.2 kilogram per meter cube. And the frontal area. So into the aerodynamic calculation, there is a requirement of frontal area. So there are few methods, either by software simulations or there are graphical methods, or also there are approximation methods. So by approximation, let's suppose I have taken the frontal area, which is 2.5 meter. And the efficiency of the motors, let's go, whichever the motor I am using, it is not 100% efficient. Let's suppose the efficiency of that particular motor will be 90%. So these are the parameters which is being already I have given. And based upon these parameters, what we will be doing, we will be calculating the force required to accelerate the vehicle. So for that, so force required to accelerate the vehicles, which is mass into acceleration. So can anyone calculate and tell me what is the answer? Like force M, which is given, I have given here, and acceleration. Let's say acceleration, it is the final velocity minus initial velocity divided by the time. So 100 minus 10, what it is? Can anyone do the calculation with me and try to convert this kilometer hour into seconds? Yeah, is anyone doing? So let me. So mass is 1500 and my final velocity is 100. So initially it's 0 and here I am dividing it by 10. So here the 100 is in kilometer per hour. To do the conversion of 100 kilometer per hour into meter per second, what I will be doing, I will be simply multiplying it by 1000 and dividing it by 3600. So can anyone tell me what is the value of this one? Hello, I'm audible.
Sir,
Yeah, can anyone do the calculation with me? Yeah, just try to calculate like what is the value.
4166.6.
4170. This one.
So approximately.
Yeah, approximately. So 4170, let's say this is the fourth calculation. Then we will be calculating the rolling resistance, which is RR. So the formula for that is mu RR. So this one, mu rolling coefficient into mass into acceleration, which is mg. So let's suppose my mu RR it is and mass here it is 1500 kilogram and that's velocity to gravity is 9.8. So what is the final value?
Four thousand 41.
41.
the 441.
Yeah, I got the two answers.
441.
141 and one more. Someone else was
41.
saying. So how many for 441? So it is 441 Newton. So we have calculated the force due to acceleration. Then we have calculated the rolling resistance. Now we are going to calculate the aerodynamic. So for it, aerodynamic drag or aerodynamic force, it is half into air density. So what is the air density? It is 1.2 and the drag coefficient. Yeah, drag coefficient, which is this one. This one is the drag coefficient, which is 0.3 and the frontal area. So what was the frontal area? 2.5 meters square and the velocity is square. So what is the velocity here? Yeah, so velocity, what you will be taking? Velocity here. So we will be taking the final velocity here. Okay, so 100 kilometer per hour. So this one, this V should be in meter per second. So if we convert the 100 kilometer per hour into meter per second, then what it is? Yeah, can anyone say? Yes.
V square is 771.
I didn't get you. Can you tell me?
V square is 771.58.
Yeah, is it right? Yeah, from the audience participants. Yeah, can anyone tell me like what is the final value of this one?
Sir, something about 6,700K.
1700K. I don't think that this value should go this much, because this is a very huge value. So I think so. You might have done some calculation mistake. Try to correct it.
Sir, it's just 1,708.
1,700.
1,708.
Let me calculate because I am confused like how this much value you are getting. So this is half and this is 1.2 and 0.3 and this is 2.5. So if we multiply it, what will we get? Yeah, kindly do the calculation.
Sir, 868.
868. No, I don't think so. 868. Kindly, like what you have done for V, what it is? Simply V. So it is here, the V is 100 km per hour, but I want this in meter per second. So 100 will be this much. This one will be in meter per second. So simply do this calculation. I think it will be here about 27.7. And this V here will be V square. So 27 into 27.7 square, what it is? Can anyone tell me?
Sir, 769.
Final answer, 769.
No, sir, B square only. B square.
Final will be 863. Approx.
Yes, sir.
So I think the answer will be near about, if we calculate, like it will be near about 740. It will be near about 740 Newton. So here I have calculated the force due to acceleration and the rolling resistance and the aerodynamic drag. So what I will be doing, I will be summing up this. Like I will adding all these values. So kindly add this value and tell me what is the exact value of total force. Like what is the total force? Kindly add all the forces and tell me what is the value of that. Hello?
Sir, 1591.
1591. I think the first one was 4,000 and the second one is 441 and this one is 440. So what it is?
Oh,
if you
okay, sir, my mistake.
Yeah. So what is the final force? It is 5,000 something. Kindly calculate.
5,181.
Again 1,000 you are getting.
No, sir. I said 5,000.
Oh, 5,000 what?
181.
5,181. So this is in Newton. So this is the force I need to move the vehicle. Now I want to know the power. So for power, the formula is force into velocity. So what is the value? So velocity is here 27.7. So this velocity. So if you multiply this value 5181 with this velocity 27.7, so you will be getting the value which is
143,513.7.
yeah. So 5181 by 27.7. So it is about 143,513. So this is in Newton. What is the unit of power? This one will be in watt. So if we do the conversion of watt into kilowatt, so it will be near about 153.5 kilowatt. So this much rating power of motor we required for the traction purpose. So this is a brief, a simple calculation which we are doing to analyze the motor power requirement. So these are the steps which is being involved. So for to getting the more precise value, we move to MATLAB software or the different simulation software in which upon which we get the good efficiency of our calculation by using those softwares. So I will be taking toward the MATLAB, simple MATLAB module also. So I hope you are clear with this calculation. So now this was about the motor and the motor selection. Then we will be talking about the power battery because it is the main part of the EV powertrain. So talking about the battery, so the different types of battery depending upon the form factor are present, which are cylindrical, prismatic, as well as the pouch. So in pouch cells, which are being used into our phones, and talking about the cylindrical cells. So these simple cylindrical cells are connected in either series or parallel configurations to get the fulfilled requirement. So simply as we have calculated the motor calculation, then after that motor calculation, we also do for the battery pack calculation. So after the calculating the battery power as well as the energy required, like depending upon the range estimation, all these things. So this cells is being also configured. And then we have here the prismatic cells. So you can see here the prismatic cells. These are cylindrical in nature. And then, so what is the difference between the different form factors? Its simply difference is that by changing the form factor, either cylindrical, prismatic, or pouch, we get AH difference in the AH rating, and also by changing the chemistry, like there are LFP, NMC, lead acid, we get the variation into the voltage. By changing the form factor, we get the capacity change, and by changing the chemistry, we get the change into the voltage level. So this is about battery. Now here are some terminologies which is being used for the batteries. They are voltage, capacity, energy density, power density, C rating, SOC, and the DOT. So simply whenever we have a battery cells, a single cell. So let's suppose this is a 186. This is very popular cells which is being used into the electric vehicle. So these single cells have the voltage of 3.7 volt, which is a nominal voltage, and the AH it may be 2600 milliampere hour. Like we have phones, we have seen like 5000 mAh, 6000 mAh. So this single cells having 2600 mAh. Then we have the capacity. So this capacity, this one, the capacity of means this part only. Then we have the energy density, like how much energy is being stored into the single cells. So can anyone tell me, like this is my cell, of voltage rating 3.7 volt and having the capacity of this much 2600, what will be the capacity? So can anyone tell me? Just give me a formula for like how I will be doing. I'm not asking the exact value. I have the voltage and I have the AH capacity, AH ampere hour, and I have the voltage. I want the energy density, what it is, what it will be.
Something VI square formula.
VI square. No, it will be simply the energy is here power into time, and for power into electrical it is V into I into T. So simply the voltage is this much, this one, and I here is H A ampere, this one, and H will be here. So simply multiply this 3.7 into the 2600 and you guys will get the energy density, and the power density is also there, which is the watt per kilogram. Then we talk about the C rate. So C rate means like how fast we are doing the charging as well as the discharging. Normally we do the charging or discharging, and like we do the charging near about 0.8, 0.9 C, but talking about the discharging, we do the discharging near about 0.1, 0.2. And this is SOC. So SOC means the state of charge, which means that like where we have phones. So what is the percentage showing into that? So that is the nothing but that is SOC, which means the state of charge, that how much energy is being present into the battery pack. Then we have the DOD, which is depth of discharge, like how much energy is being used. So that is DOD. So this is about the battery as well as the motor and the architecture. Now we will be moving towards the MATLAB model of the electric vehicle architecture. So this is the block diagram. Like into the MATLAB, what we will be seeing, like we have the drive cycle, which is being connected towards the driver controller. Then we have the power converter, which is responsible for the dynamic responses by the driver. So drive cycle is nothing a driving pattern, which is being it is a set point between velocity to the time. So it defines like when we are increasing the speed, when we are stopping the vehicles, like the variation depending upon all the tractive forces, all the other forces. Depending upon that, every country have their own drive cycles, and these drive cycles have been fed into these driver controllers, like a person who is being accumulating or moving the vehicles. So he is moving the vehicles. Then after that we have the power converter. Then this power converter is being connected to the motor, and we have the battery here. Suppose if we are using a AC motor, then their power converter will be a DC to AC conversion, and then the motor will be powering up the vehicle body. So vehicle body will be consisting of all the forces. Like earlier we have calculated the different forces that is being fed into this vehicle body block of the MATLAB, and that depending upon that we take the motor, and then depending upon that motor we take the battery pack. So this is a whole like you can say the few steps involved into the calculation part of this electric vehicles or any conventional vehicles. So moving towards the MATLAB, let me open the MATLAB first. So this is the model, like I showed here. This is the drive cycle. So in drive cycle, this is the pattern of the drive cycle. You can see like FTP, which is running for about 2474 seconds, and we can see the speed variations. Like if we increase the so you can see here there are the patterns. Like suddenly we are increasing, suddenly their vehicle is being for ideal condition, like the variation into the vehicle speed. So this is my reference speed which we are feeding to this driver. So this is the driver. So the vehicle reference is being given here, and here it is the grid, which means that inclination there if there is no. Now if there is acceleration command needed, then it will be give the command to this control system. If there is deceleration needed, then it will be giving to this H breeze, which is representing here the PWM pulse, the reference as well as the reversal, and the which is here the regenerative braking, and here the braking. So whenever there is deceleration, it is being given to this brake, and this H breeze here is acting as a control system which is responsible for decreasing or stopping the vehicle. So you can see here, this is the drive cycle which I showed into the presentation. This is the driver controller. So driver controller, and then we have here the control system, which is this one, the power converter. Now moving towards the, this is my motor. So motor, this is a DC motor I have used here. And talking about the battery, so this is the battery. So you can simply see here, this is the battery. I have taken the nominal voltage as well as the AH rating. Everything is being fed into this battery. So depending upon the calculation, we give the data to this battery model, and then depending upon the motor and the other things, the stored energy from the battery is fed to this motor, and then we have here the vehicle body. So when this is a subsystem, when we open this, so you can see here, this is the vehicle body. So all the calculation depending upon the vehicle weight, what are the other parameters, so we fit it here. And we have here the, suppose it is a two-wheeler or three-wheeler or four-wheeler. So depending upon that, we set up the wheels onto the axis, onto the axle. Then we fed up the values. So all the calculation, we simply give the data here into this MATLAB, and then we get the required output. So this is how we do the simulation into the MATLAB. So this is how we are connected all the blocks. So when we run this, all the when we run this simulation for 2474 seconds, so you can see here, it will be showing and like how much distance this vehicle is being covered. So the vehicle covered a distance of 1.414 kilometers. So depending upon the value, the speed as well as the distance will vary. So this is how we do a general calculation of the electric vehicles onto the MATLAB. So I hope you are clear from this MATLAB model and how we do the calculation as well as the connections of the different part of the vehicles. So that was all from my side. So any questions you have, you can ask.
Sir, can you share that MATLAB model?
They will convey the management team to share.
Yes, it would be better if you just share it to us.
Okay.
Yes,
We'll
it would be.
convey.
Sir, what is the difference between the calculation part of MATLAB or
In MATLAB, like we have blocks already present there. Like there are hectic calculation present, like different day, like they are very dynamic calculations. If we go to calculate mathematically without using any softwares, we will not get the precision or the accuracy into our result. So by using these softwares, we get the precise result. Okay, we get the accuracy into our like whatever the things we are taking as whether it is motor, battery. So we will be getting a accurate value for that.
So this is the signal processing, maybe in MATLAB.
No, this is I have done on SimScape.
Simulation.
MATLAB simulating SimScape.
Yeah.
Sir, any other softwares available for this?
Yes, I didn't get you.
Sir, you told MATLAB, isn't it? Any other similar softwares available for modeling electric vehicle?
There are PSIMs, PSIM softwares, MATLAB, and also ANSYS not. So for that, you can use PSIM also. Into PSIM thing you can do. There are few softwares on which you can do the vehicle dynamic calculations as well as the simulation. But I will be recommending that In MATLAB, you get the like you have more options like motor, battery, vehicle body. So there are other software which are doing only dynamic things.
What is your purpose of using HVAC?
Yes.
What is the purpose of using HVAC?
Actually, so it is acting as a controller. Like we know that four quadrant operation. So for that performing that four quadrant operation, we are using the HVAC. So for that, you need to go more depth into the into this HVAC thing.
So based on this value, we can select the motor of same size.
What? Yeah, I didn't get you. Can you please speak again?
Sir, we can we use Blue Prism as a modeling?
What?
Sir, for modeling purpose, can we use Blue Prism?
Blue what? Blue Prism?
Blue Prism, it's also software. Yes, sir. It's for graphical representation, or something modeling, or various processes.
So I didn't have the idea of that particular software. And like, what is the name of that particular software you said?
Blue Prism, sir.
Blue Prism.
Yes, sir. So it's a robotic automation process.
For automation, but like I don't think that it will be able to do this MATLAB like modeling, mathematical modeling. So I can't.
Sir, for in that software we can do calculation part.
In that Blue Prism.
Yes, sir. So I don't know actually, sir. I just have a doubt.
Currently, I also didn't have the idea of this Blue Prism software. Okay, so there are softwares which are present for the simulation. So it's better to do command on only one software because if you command on only one software, then it will be good for you. Because if you try to get knowledge of different modeling software, then I don't think it is very beneficial for you.
Okay, sir.
I have a question that based on that simulation value, we use that same value for designing the motor.
Sir, can you please speak again? I didn't get you.
Based on the value that shows in the MATLAB simulation, that same value designer will use to design the battery pack and motors and others.
Like talking about the value, so it totally depend upon you, sir. Like what is the vehicle specification you are trying to design, or else you can, for your convenience, you can like for practice, if you want to do the like a rough idea, like whether I am doing the same calculation, you can refer a reference paper. From that, you can put the value, take the value, and then you can fit into your model. Then, if it is getting the same result, then you can say that your model is perfect. Okay, so I think everyone is clear. So I think okay. So that was from my side. Thank you. Over to
Sir,
ISIEINDIA.
I have a question, sir. Do you have any plan to provide webinar on EV chargers and charging infrastructure in future?
So this ISIEINDIA team will be handling these things from you. Okay, thank you.
Thank
Hello.
you, sir.
Yeah.
Thank
Hello.
you, sir.
Yeah, Vivek, we will be organizing the session on the EV charging soon.
Okay, thank you, sir. Kindly let me know.
Yeah, okay. So
Okay,
thank you,
thank you,
everyone.
sir.
I hope you like the session.
Yes, sir.
What about attendance and feedback link?
So I would like to inform here is like we have started internship program for the student, those who want to join the internship program for 4 to 6 months. We have internship on different topics like designing of the go-kart, designing of the formula car, designing of the solar car, the EV design and development, and other topics as well. You can easily visit our portal www.isieindia.com to see the internship program that we are having. Apart from that, we have different products or different courses available for all of you, and you can easily watch the video I will show you right now. And if you guys are interested in any of the program, just let us know. We will share the link in the chat box.
Sir, I have one question. Can you please answer it?
Yeah, in 5 minutes, I will answer the questions. Just give us a minute. I will play a video, then I will take up the question. Okay.
Okay.
Okay, please.
Hello engineers, do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV CAD and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship, to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV Powertrain Training and Research Lab, Battery BMS Training and Research Lab, EV Charging and Battery Swapping Lab, Software Modeling and Simulation Lab, Innovation Lab and Renewable Energy Lab. Each lab consists of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off-grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions, and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with their journey towards success. Join us and take advantage to unlock endless career opportunities.
Thank you everyone for watching the session. Thank you for watching the video as well. So as you can see, like we have a different products available for everyone, for the students, for the working professionals who are dropped out and who are looking for the jobs. Apart from that, if any college wants to establish a center of excellence, we have a specialized center of excellence for each and every college, and that is too funded by National Skill Development Council. So if you guys have any question related to the courses or anything, just let me know so that I can give you the.
I have one doubt.
Yes.
So what is the exact scenario of play after placement?
I didn't get you.
What is the exact meaning of play after placement? Means we have to pay our money after the placement, or initially we have to pay something?
Yeah, actually how this course works is like this, the course that we have of total duration of 12 months. Okay. And before 12 months, we will give you 3 opportunities to clear in the OEMs. And once your course duration is completed, let's suppose 12 months is your course duration, from 13 months, you have to start paying the course fee. Okay. But before the completion of the course, you will be getting 3 opportunity in the industry itself. So it's up to you how you are going to clear the interview, but our responsibility is to get you in the interviews of the OEMs.
Okay, sir. So if X was a person is paid in an interview, so we have to pay the full payment of the player.
No. It works like once you complete the course, you will get 12 months of duration to pay the entire amount. Let's suppose the course fee is 1,20,000, you have to pay 10,000 rupees per month plus interest of around 700 rupees every month. So this course is adopted by most of the students, those who are in the final years. And if you are in the final year, that is best suitable for you, because currently, as we can see, like most of the EV industries are recruiting, and they are recruiting the students, those who are more technical towards the electric vehicle technology. So if you are interested, then you can register for the same. And during the course duration, you don't have to pay anything. And before the course completion, we will give you 3 opportunities to clear the interviews. And then once you are done with your course duration, the course, then you can start paying the fees. And that too in the EMIs.
Is there a 6-month course available?
6-month course is available, but we are not giving the placement assurance in that. We are giving the placement assistance for the student. In that case, how it works is like a student enroll in a 6-month program. We do share the resumes with the industries, but we cannot commit that we will give you the 3 interview chances in that course. So if you are interested, I will share the QR code over here, and you can fill up the form. And this QR code is only for the student, those who are the professionals, those who are interested in the course. They can fill up the form and our counselor will get back to him. If anyone has any question, you can ask me here. If anyone has any question, please ask it here. Or else if you are done with the session, you can leave it. Or if you are interested, you can just scan this QR code and fill up the form over here. And for the certificate, you will get the link on your emails. You can download the certificate from there easily. Okay, you will get the steps how to download the certificate in the email itself.
Thank you, sir.
Yeah, thank you, Randan. So thank you, everyone. If you are done with the session, you can leave the session. If you guys are interested in the course, you can scan the QR code over here and then fill up the form.
Thank you,
Sir, I have a question. The power distribution companies are also involved in the EV charging infrastructure. So any of your previous students have got placement in any power distribution company by pursuing the course? Any idea about that?
The power distribution company, I'm not sure of, but our student got placed in the two-wheeler and the four-wheeler company, those who are manufacturing the EV right now.
Okay, so they are the automobile industry, right? But this EV chargers, and they are all handled by the power distribution companies of different states. So like, and many of them are private also, like this Tata Power or BSES.
Yes.
So students are getting placed in those companies also, or like in automobile?
The students are getting placed in those companies. But actually, right now we have a tie-up with the automobile industry. We are currently looking to expand our tie-ups with those companies as well. So once we are done with that, we will be sharing the resumes of the students to them as well. But yes, those students are capable to apply for these posts as well. Where you are, which one you are telling right now?
Okay. Thank you, sir.
Yes, thank you, sir.
Sir, I have one doubt, sir. Shall I ask, sir?
Yes, please.
Sir, for nowadays, most of the EV vehicles have a battery management system.
Yes.
Though the management system does the job for equal charging, discharging, them, it has been monitored. Then how come the batteries are getting fired, sir? So recently, yesterday also, bikes got fired. So I would like to get the good answer from you, sir.
So Mohan, actually technical person, has left the session. He is the right person who can answer the question. But I can say that the BMS plays the role, but the BTMS is also important in a vehicle or in a battery. So without BTMS, if we are having the BTMS, we have done the BTMS of a battery, then it is not going to catch the fire. But you can do one thing. You can share a question in a chat box. We will share it with the technical person, and then he will get back to you over email.
Okay, sir. Okay. I'll just text it.
Yeah, please.
Thank you.
Thank you. So if any student is interested in a summer internship program, you can join. The link is available in a chat box. You can fill up the form and you can easily apply for the internship program.